All right, guys. All right, thanks for the introduction, Gopi. And then, so hi everyone. My name is Wang. I'm an associate professor at York University. And then today I'm gonna share my recent work on advancing automatic software engineering in the year of LLMs. Okay. I cannot, yeah. All right, so, yeah, technical issue again. All right, so we're now in the AI year, right? So I would say we're in the AI year, and then so the paradigm of software engineering, automatic software engineering, has been significantly changed, right? So with the help of LLM, so developer can directly wrap up their software development task as a prompt. So sometimes the prompt can even include the code, right? And then the prompt can be input into LLMs for generating solutions. For example, you can ask LLM to generate test cases for a specific piece of code. And then you can also directly put a pure natural language description and ask LLM to generate solutions, right? And then sometimes you can also ask LLM to generate patches for a given bugs, right? So, and then recently RAG was introduced. As Justin introduced, RAG can provide up-to-date and accurate information that can help generate more informative solutions. And then when it comes to automatic software engineering, RAG can provide a lot of useful information, up-to-date information from a lot of different external resources. For example, the GitHub and Stack Overflow, even documentation, email archive, and user discussions. And then, our recent effort on advancing the automatic software engineering tasks in the year of LLM basically from 4 different directions. So the first one, we want to enhance the prompt by either using Clarify approach or optimizations. We consider that actually as a pure optimization issues. And then the second directions, we want to enhance the prompt by using RAG. So if you look at RAG actually, the most important thing for RAG is actually the knowledge base. And then we want to explore what exactly the importance of different knowledge base. For example, in software engineering, you can build a RAG on GitHub issues, on Stack Overflow, and also on documentations. So which one should we choose? Should we combine everything together, or we only pick a specific one for a specific task? And then following by that, another direction we work on is we want to examine whether we should always pursue the state-of-art LLMs, right? So, and then we try to fine-tune the small FM, on specific tasks. And after that, we also want to ensure the reliability of the benchmark of the metrics. So most of the topics I think are already covered by our colleagues from Huawei, but for my talk, we're gonna be more focused on automatic software engineering, how we're gonna examine their different formats and show their the impacts. All right, so let's go to the first one. So in this project, we actually focus on code generation. So we want to improve LLMs by clarify the intention. And then, so if you look at this paradigm, this is actually the current paradigm of how developers interact with LLM to generate code, right? So from the very beginning, the developer actually have natural language describe the comments or requirements and then input it to LLM and ask for a solution. So there's a lot of papers in the last few years. Even for our own team, we have a lot of papers on this. So despite the remarkable performance, so we found that there are 2 very critical issues. The first one is users are human beings, right? Even the senior developers are human beings. Humans make mistakes. Sometimes we can even cannot even articulate what exactly the requirement we want, right? So when you build a software, there are a lot of different requirements. Even developers, users cannot even clearly describe what is the requirements. And then the worst thing is that LLMs do not have the mechanism to correct the incorrect requirements, right? So even you input the incorrect requirement, LLM cannot correct the incorrect, right? So here, so LLM directly generate the code given whatever requirement you input it, all right? So here we have an example. If you look at the requirements here, there's a small issue in the requirements in the natural language prompt. Anyone can tell me what's the issue here? So look at the requirement. The user said, write a function to sort a list of elements. Right. Anyone can point out what's the issue?
The language is not defined?
Yeah, the language is not defined is one thing.
Type of elements is not defined.
Elements not defined is another thing. But it's actually wrapped up in the description. So this is one of the questions from MBBP. It actually tell you should write the code in Python and the elements are integers.
The complexity they are looking for.
The complexity, okay, another issue. Yeah, you can see there's a lot of issues here, right? Ahmed.
Like sort them up or down.
Yeah, that's good. Yeah, so that's the answer I expected. So if you look at the description, actually it did not give it clearly hints. So whether we should rank it ascendingly or descending, right? So, and then if you do not have those kind of requirements, LM can infer the requirement based on its own probabilities. And also LM has non-deterministics. So if you run the module multiple times, you're going to get some different solutions. Sometimes you have the solution that with descending order, and sometimes you're probably going to have ascending order, right? So, and our observation here is that for those ambiguous requirements, so we call those ambiguous requirements. For those ambiguous requirements, they often lead to semantic inconsistent code among different solutions, right? So which means you can group them into multiple different solution set. Okay. All right. And then to solve the issue, our approach is pretty straightforward. We define a human-in-the-loop requirement clarification approach. So still the same example. Let's say the user asks a question, and then what if the LM can actually find, there's ambiguity here, all right? So if LM can ask a question to clarify the ambiguity, for example, it asks, should the sorting be in ascending or descending? And then the user can actually clarify, right? So directly tell I want to rank all the elements ascending in ascending order. And then the LM can regenerate the code by combine the original prompts and also the clarification question answers, right? And then generate the code, right? So this is the main idea, how we're going to clarify the question. However, there's a lot of challenges. So the first challenge is, when should we ask a question? How do we know the question, the prompt actually contain ambiguity requirements, right? And then the second challenge is, okay, so even there's ambiguity requirements, what kind of question should we ask? How do we clarify the ambiguous requirements, right? So, and this is our framework. For the first challenging, what we do is, given the requirements, all right? So we're actually going to generate a set of different tested data, and then we also use heuristic-based mutation to generate the more high-quality input data. And then we're using the input data as a baseline. And then we use the original prompts to generate the solutions. We generate a set of, I think we generate more than 100 different solutions. And then we run the solutions against the test inputs. All right, so assumption here is that if the requirements does not have any ambiguity, so the solution should converge. So which means we won't have a different behavior on the same set of test cases, right? And then, all right, so after that, after we check in the consistency we're gonna, if we find that there's ambiguity in the requirements, and then we're gonna go to the next step. So the next step is what kind of question we should ask, right? So our original design is we have to keep human in the loop, right? So we want human in the loop. However, so human it's not practical to always keep human in the loop. So our solution here is that we actually fine-tune another LLM to directly the LLM we fine-tune is to ask questions. Given the ambiguity requirements, we're going to ask questions. All right. Okay, and then when you get the answer from user, so the LLM going to combine the original requirements and also the clarifier from users and regenerate the source code. So this is the whole process. All right, so and then to evaluate the approach, we actually recruit a set of different participants, including students, research, and developers. And then everyone have at least 3 years Python programming experience. And then we also pick 2 of the widely known baseline. The first one is Chain of Thought, and the second one is GPT Engineer. So GPT Engineer is one of the most popular framework on the market. It already has more than 52K starts. And then we're picking 2 datasets, MVP and Human Evolve. So you can find the results is shown in the table here. So from the table, you can find that our ClarifyGPT can actually outperform all the 2 different baselines. So the improvement can up to 30%, which is pretty impressive, right? All right, so here we'll still keep human in the loop, which is which a little bit in practice, because you cannot always keep human in the loop, right? So and then we also propose the alternative solution. That is, we actually want to simulate user feedback generated by LLM. So what we do here is we actually train another LLM to directly answer questions. So here we have different LLMs. Some of the LLM we train LLM to ask a question, and we train another LLM to answer the question. It's more like engine paradigm, but we didn't call it engine. And then the results here, we actually apply them on different data set. You can find that so the stimulated feedback is not bad. It's sometimes even better than human beings. For example, here on the GPT-4, it's even better, even better than human beings. The possible reason could be sometimes, as I said, human beings are not even clear about the requirements, right? Could answer the question incorrectly. All right. All right, so.
So does the simulated feedback peak at the test cases?
Yes.
Okay. And then the difference here between ChatGPT and GPT-4 is
It's only
3.5?
It's only the backend model. Here is ChatGPT 3.
Okay.
Yeah, we're using the backend models, right? Different backend models.
So in either case, this is being called from the API, right?
Yes.
Okay. Thank you.
All right. Okay, so we said we're gonna beat GPT Engineer. So we need to show some proof of why we can actually beat GPT Engineer. So this is one of a real case from MBBP. Still the same example. Write a function to sort a list of elements. So using the GPT-3, so actually we cannot get the correct solution. You can see that GPT-3 actually generated very complicated results. Cannot pass any of the test cases. And then both GPT Engineer and our ClarifyGPT can actually help developers solve the issue. However, if you look at the GPT Engineer, so GPT Engineer have manually designed the template to ask questions. So no matter the question is simple or difficult, it will always ask questions. Even there's no ambiguous in the requirements, you're gonna still ask questions. So for example, in this example, GPT Engineer asks 5 of the questions, and some of the questions you can directly find an answer from the requirements. Let's say here, do you want the entire implementation of this function, right? So it's pretty clear. And then our ClarifyGPT is more flexible. We only ask one key question. So what's the order you want to sort, right? So, and then compared to GPT Engineer, we actually ask much less question. So on average, we ask 3 less questions. And also, we don't ask unnecessary questions like GPT Engineer. Okay. All right, so that is our first piece of work on enhanced prompt. Followed by that, we also think about the prompt enhancement task from optimization perspective. So if you look at the way how human beings interact with the LLM, it's more like we input something into a black box, right? So we don't know what exactly input is going to trigger the key to generate this solution. So it's more like the traditional optimization issue, right? So here, we're actually using the search algorithm to explore the variations of different formats. So what we do is we're going to generate different variants for a given prompts, and we're going to input the prompt into the LLM to see whether we can actually generate better solutions. So the assumption here is that we assume the prompts that have a better alignment with larger language models training data, either with a specific format or containing or include a specific words, going to have a better performance. All right. So still the same example. So given this prompt, if we say write a function to sort list elements sandling, if you put this prompt into LLMs, you could get a correct solution. However, if you change the words sandling to upwarding, all right, so this is pretty much the same thing, right? Semantic equivalent. However, so if you change the prompts into LLM, so you won't get the correct solution. So this actually means a better alignment with LLM's data could help us get more accurate results. Right? So motivated by this example, we actually propose a APIC is optimization prompts. So we actually consider the prompts optimization as a typical optimization issues. For example, we have fitness function. So in this task, we consider the pass rate. So how many test cases we're going to pass as a fitness function. The more you pass, the higher priority we're going to give. And then we also propose 2 different mutation approaches to generate the mutants. For example, the first one is LLM based. So given a prompt, we directly use another LLM to generate the prompts. And then another one is similar words replacement, just like I showed here. Simply replace the words randomly from your original prompt. So we want to see whether it's going to improve the performance or not. All right, and then we're following a very traditional optimization approach. For example, we generate the initial test and solution, and then we evaluate the general code, whether it's satisfied. If not, we're gonna run the whole optimization process, and then we build the initial population. We actually augment it by 10 times, and then we evaluate the prompts, each prompt by calculating the fitting function. All right, this is going to be the whole loop until we're reaching the threshold, or get, for example, the minimized fitting function. Okay. All right, so we actually, to evaluate our approach, we pick 3 baseline. So the first one is the reflection and ADB and last. So the first one is actually feedback driven. So we're doing the optimization, so it's similar to feedback driven. So we pick 3 similar approach. Most of them are feedback driven. For example, the last, this one, agent plus search algorithm. And then, so the table actually shows the performance. If you look at the table, you can find that, again, so our approach, APIC can actually outperform all the 3 baselines on both of 2 different data sets. And not only the performance, pass 1, but also the cost. We actually need less money. Also, we need less time. All right. So actually show the pure optimization algorithm can actually help to refine the prompts. All right. So followed by that, so another piece of work. So above all, we show how we're going to refine the prompt itself, right? So we didn't actually introduce external knowledge. However, if the prompt is not informative enough, right? So we won't able to generate correct solution, right? So what we want to do here in this project is that we actually want to examine whether we can use RAG to improve test case generation, right? But if you look at RAG as software engineering, specifically for test case generation, we actually have different external sources. For example, given an API from project, right? So you can find a lot of discussion on Stack Overflow. For example, for TensorFlow, right? So there are a lot of discussion on Stack Overflow, how to use a specific API. And there are also a lot of good and bad example on Stack Overflow. And then this is actually QA knowledge, right? So we call it QA knowledge. And then there are also a lot of other knowledge from GitHub, right? So there's documentations, the code, and then there's also documentation, right? So there are different type of RAG knowledge. So which one should we use, right? Should we combine everything together, or should we only pick one of them, right? All right. So to figure out the answer, we actually build a framework. So given an API, we actually first of all collect all their documentations, and then for each of collect documentation, and then we also collect for the API. We also collect all the discussion on the Stack Overflow, and also there's issues in the GitHub. We also collect the issues, and then we build the vector B. And then we actually build two different RAGs. So the first one is the basic RAG means we actually build a RAG for a whole project, right? So we didn't distinguish the RAGs between different APIs. And then the second one, we build a API-specific RAG, which means for every single API, we actually collect all the resources, all the external knowledge, and build a RAG. And then we want to see whether there's a difference between the more comprehensive RAG or a more specific RAG. Okay, so yeah, we actually generate unit test cases and evaluate by using different metrics. So for this project, we actually examine 4 different LLM baselines, for example, GPT-3. Those are 2 commercial LLMs, and we also examine 2 open source FMs. So we actually choose 5 deep learning frameworks as our subject. For example, TensorFlow, PyTorch, sklearning, GoogleJar, and XGBoost. All right, so we focus on 4 different metrics to see how well the code generated are. We're not only focused on F1, we also focus on the pass rate. For example, whether there contains syntactic errors. And then their execution rate means where there contains semantic errors. If you have semantic errors, your code is passable but not runnable, right? And then we also see the pass rate means how many test cases can actually pass, right? And then we also check the code coverage, all right? So here, there's a lot of results in the paper. I don't have a space to show everything, so I only show some key findings here. The first finding we found is that RAG indeed can improve test case generation, no matter which resource we use. For example, we build a source from GitHub, from Stack Overflow, from documentation. Every single RAG can help us improve the test case generation for deep learning libraries. And the second thing is we found that API-specific RAG actually perform better than the more comprehensive RAG. For example, if we build a RAG for RAG database for a specific API, we actually can generate better test cases for that API than using the more comprehensive RAG. Okay? And then the third thing is we found that it's quite interesting. We expected that Stack Overflow going to be the most powerful knowledge base. However, the GitHub issues benefit RAG more than another 2 different external sources. So we show the reasons. I think the reason could be compared to Stack Overflow or documentation, GitHub issue actually going to cover more corner cases. This is actually related to how we're going to report errors. If you look at the GitHub issues, when you want to report an error, so nowadays you should follow the guidelines. In the guideline, you have to describe what the issue is, what API you call, how you call API, what is the input value, right? So what is the environment, and all those things put together, gonna give you a very good example to how call the API incorrectly. So the knowledge from GitHub actually gonna benefit the RAG to provide a lot of incorrect usage knowledge to help us cover more corner cases. So the RAG built up on GitHub issues, eventually RAG built up on GitHub issues help us cover more code, find more bugs. All right, so another direction. So we actually want to try whether we should always pursue large FMs. There's a lot of different large FMs, large language models. So over there, for example, GPT-4, 4.0, and then a lot of other Llama Cloud 3, right? So most of them, commercial LLMs are not free. You have to pay. And then it's not necessary. We find that it's not necessary always to pursue those state-of-the-art large language models. Sometimes the small ones should be enough for software engineering tasks. I think it's really because for a given project, specific project, the knowledge base is pretty limited. We don't need very huge large language model. Fine-tuning a small one should be enough. So here, just want to give you a little bit background knowledge of what is the fine-tuning, why we need fine-tuning. So actually, the fine-tuning is come from, the reason why I need fine-tuning is because there's domain shifting issues, right? So the knowledge from two different domains are different, right? Because the concept of drifting issues, so fine-tuning can actually mitigate the issues. And then also regarding fine-tuning, there are different levels of fine-tuning. So you can do the domain level, we call domain adaptation, right? So for example, you fine-tune for a specific project using the history data of the same project, we call domain adaptation. Because we fine-tune at a small scale for project level. And then there are also task level. For example, you fine-tune for Python programming, you fine-tune for JavaScript, right? So those are, we call fine-tune at task level. So in this task, we actually want to look at combine both the task level and project level. Okay, so this is the overflow of our approach. What we're doing is we actually combine fine-tuning and domain adaptation. So the task in this project is test generation, but we focus on a more challenging level where we want to generate test cases cover specific line. So it's going to be line level code test case generation. And then it's pretty challenging. If you look at the available tools, solution on the market, so basically there's no solution for, we only target at the line level. And then we don't have any on the hand tool to use. So what we did is, first of all, we need to build a data set, right? So we build the test and the line mapping, and then we fine tune at task level, which means we fine tune at for Java project for software testing. And then we fine tune a very small code module, code T5. Anyone know code T5? Its parameter size only 200 million compared to several billion parameter size of ChatGPT, right? It's pretty small. And then the first part is fine tuning. After that, we also do project level domain adaptation. So we examine with the 5OJ project, where we will split the project into training part and testing part, all right? Okay, so the solution is actually very inspiring. So if you look at it on the figures here, so the yellow bar here actually shows the performance of GPT-4, which is state-of-the-art large language model when we conduct the research. So without a domain adaptation, Qt5 without domain adaptation is shown in the blue. You can find that the performance is pretty poor, right? So it actually cannot beat some of the deep learning modules. And then after we conduct fine-tuning and domain adaptation, you can find that Qt5 with domain adaptation, we can actually beat ChatGPT-4 on a lot of different metrics, all right? So you can see we actually can narrow down the gap between small module and large module with fine-tuning and domain adaptation. Okay. All right, so yeah, so this is going to be the last piece of work. So above all, I briefly mentioned how we're going to enhance the prompt, how we're going to fine-tune the module. But however, if you evaluate the module, the benchmark is very important, right? So we also want to examine the reliability of benchmark on the market. So in this work, this is actually one of our recent work. So we want to examine how reliable the benchmark is. So we pick one of very popular one, the SWE bench. Anyone know this? I think Justina just introduced. SWE bench is one of the very popular widely used bench line. The covering 200 issues from 12 different projects. And then they also include not only the issues, they also include test cases to have you examine whether your solution passed or not. So there's also a lead bot to show the performance of your modules, all right? And then what we do here is, if you look at their performance, on the light and verify, some of the modules can even achieve 50% pass rate. It's really high. And then here we show the performance on the full data set. It's 20%, it's also pretty high, right? So one of the questions here is, are those models really good? So from another point of view, so should we, is the benchmark really reliable or not? All right, so what we did here is we actually conducted robustness analysis. So we actually pick one of the module, SWE engine plus GPT-4, which is state of art when we conducted with this research. So what we do is we actually reproduce the module against the full data set. And then for each piece of data, each piece of a solution, we compare to its golden patch to see it actually fix a bug or not. We'll not only compare the patch, we also look at the title, the issue titles, the discussion, the test cases, right? So a lot of different informations to verify whether the patch is valid or not. So surprisingly, what we found is more than 60% of the sub-issues are suspicious. The multiple different patterns, I only show some dominating pattern here. So the first one is solution leak. This is pretty common because when you report an issue, sometimes project also require you to figure out how to fix the issues, right? So, and then the solution are directly in the issue title. And then, so for example, here is example, when the user reported the issue, it also point out how to fix the issue. And then the large language model directly copy and paste the solution. So exactly line by line copy paste, and it actually solve the issue. However, this is going to be a solution leaky, right? And then there are also some other pattern, for example, incorrect fix. So it didn't fix the LLM does not fix the issue correctly. However, because of the test cases are pretty weak, so the patch also passed, all right? And then, so by removing all those suspicious issues, we actually found that state-of-art LLM's performance on solving the issues on SW bench actually dropped by 90%. For example, on the SEW plus, the performance dropped to 0.5. All right. So this is a pretty significant sense. When you evaluate the module, you should pick a reliable baseline, a reliable benchmark module. Otherwise, you're going to give evasion. All right. So I kind of run out of time. So in this talk, I actually introduce a piece of work how we enhance a prompt by either using ClarifyGPT or optimization or a RAG, and also we show how we can fine-tune small modules to achieve performance. And then we also show how to build reliable benchmark modules. All right, thanks.
Thanks, Professor Song, for a fantastic talk. We have time for 1 or 2 questions. So.
Okay. Thank you for the nice talk. First, I have a clarification question. What do you mean by API RAG? Like, is it just like the copy the function code and then do you provide it to the LLM, or like what do you exactly mean? Because one of them is documentation. That makes sense.
Yeah. So the API level RAG means we collect the information, knowledge for the specific API, and then we build a RAG for that specific API.
Okay.
Yeah.
And just a second question. Like when you're doing test case generation for that project, like how do you evaluate the test case? Like, is there like a ground truth, or do you do it based on like code coverage, or like how do you test? Like, is this the generated test cases like are correct or not?
Yeah, we actually evaluate test case based on their pass rate, correctness, code coverage, mutation score, all different metrics. Yeah.
Thank you.
Yeah, me.
Song, I don't know if this is a fair question to ask because it wasn't. I know that you had limited time and you didn't cover everything in the slides, but the paper that you presented on the test generation, RAG-based test generation, right? When I looked at the details, you said go look at the details. There's a lot more details. One of the things that I noticed is that for GPT-4o especially, when you included other things, when you did RAG, it actually started performing worse.
Yeah, sometimes it perform well, sometimes perform well. So depends
Sometimes,
on
yeah, but can you comment on why it's doing worse with more context?
Yeah, so the thing is, you don't know what the information retrieved by RAG is actually correct or not. If the information we retrieve by RAG is incorrect, essentially we actually put more garbage in the LLMs.
But that seems to be an impact on the newer or more, the bigger LLMs than the older ones. The older ones don't seem to be doing as badly as the newer ones are.
Yeah, still again, because if you search for, we're not sure whether the information we get from RAG is correct or not. And sometimes if you put more information, you're gonna have to say, you make the prompt more diversity. Yeah. All right.
I have a comment about your the last study that you presented on the benchmarks. I think a lot of companies there don't want to use a very good benchmark. I think there's a hidden benefit in not using a very good benchmark because then they can.
Yeah, I think that's true. Because if you're using a very harsh benchmark, the performance pretty low. It's not good looking.
So two comments. So one about the RAG thing. So what we have noticed is, so there's fine tuning, there's RAG, there's all this stuff, right? But it doesn't mean if you do this, it will get better, right? Actually, a lot of times when you try to fine tune, you end up with a worse model.
Yeah.
Okay, so there's a lot of complexities in doing this. It's not like, and that's kind of the big thing about the next 2 days, is a bit kind of from cool demos to actually production. A lot of times people say fine tuning will make magic. Actually, it's very hard to fine tune where magic happens. And then the other comment on the benchmark. So I think these are two different perspectives. So we're in software engineering, we're thinking benchmarks, so it needs to be perfect, needs to be representative. In the AI world, the way the benchmark works, it's kind of like a little challenge to gauge the progress of the community. So there are some very interesting works where people basically look at benchmarks and say, so if you have a benchmark that's too hard, the community won't actually use. So too hard meaning we spend many years on it and nobody's moving forward, or it's too hard to set up. It's a very different perspective than like the way software engineering thinks, where it's like, we want a benchmark that's so realistic. Because the reality is there's no benchmark that's realistic. You spend the rest of your life dreaming of that. It doesn't exist. Okay, Danny. Okay, it's over there. There's a question.
I agree, Ahmed. But I think this is the dance. This is the balance. Like, with the benchmark, it's too easy. It gets saturated very quickly, right? It's very easy to beat, and then people cannot make progress. If it's too hard, nobody makes progress, right? Then we heard this other dynamic that there is this other company policies, right? They want to look good, right, on their models, right? So it's a lot more interesting than benchmarks that we use for humans. I agree with that. Yes.
All right.
Prem.
Prime.
No, don't shout. We want to hear you.
I just want to make a comment that I think there are better benchmarks and worse benchmarks, right? I mean, so I
Yeah.
mean, just to follow up on what you said, Ahmed, it's not that all bad. Some are better than others.
So I think the true value is to enable everybody to make their own benchmark. That's really would be what we really want, right? So every company wants to be able to look at their data, create something representative, and then that becomes you want your own personalized benchmarks. That's my dream, really, right? And if we can have that, so you have the ones that the community is gauging is kind of progress, and then everybody at home can cook their own that they could give even to their, to OpenAI and say, show me how good you are, and that benchmark is able to gauge how good things are, but you're still keeping all your private, you're not revealing any details. Yeah, go ahead.
So I think the problem is that, like, machine learning people are just making up their own benchmarks. They should really, come to software engineering people who know what processes look like, and things like, pull issues contain sometimes everything you need to know. It's not really realistic, and sometimes there's overfitting with test cases and all this stuff. We've been dealing this for a long time. We know this stuff, but they make up these benchmarks and they create hype around them, and they get venture capital interested without any kind of grounding in the reality of the application domain.
So I partially agree with you, Ahmed, but the thing is that yes, there needs to be progress. But a lot of the work that's coming out is coming from companies, right? Like a lot of the models, the top models, they don't release the model, they don't release the data that they trained the model on, nothing except the logs, nothing else is public. And cherry picking is rampant, right? So in science, when we publish a paper and we cherry pick data, we get caught, and at least sometimes we get caught, and the papers are not accepted. We get called out for cherry picking data. But with bad benchmarks, right, there's even more cherry picking happening, and there is a false sense of, oh, this problem is a solved problem now, right? And when it is not, because look at the reality is that, yes, there is a lot of money being poured in by VCs, but the true success of these things is when companies use it, when developers use it. But when you talk to some of the developers using this, they say this is just garbage in, garbage out, right? And my worry is that this will become a bubble like Theranos. Like it'll all be hype, like a single prick, everything. And then they're going to burst, and they'll take everyone else with them, right? Even the people doing good work are going to be out, because in a couple of years, when the VC money runs out, they're going to find out that none of this actually works. So I think there's a line between good and... I know we shouldn't be spending so much time on just... There's no such thing as a perfect benchmark, but there's also bad benchmarks.
Yeah, which I think it was Prem's point, right? So don't go extreme, basically. So I think, because there's a lot of students here, they're going to think like, I need to have the perfect benchmark, right? Mm-hmm. So there is a lot of bad ones, and like SweetBenches has a lot of issues with it, right? And you're welcome to try to contribute it, and it could be a systematic, benchmarks are designed, in my opinion, not just, okay, we collected a couple of random data and this is what it is, right? So we need to balance that. And I think software engineering will be the best people. And this is an opportunity for people in the room, to actually try to contribute something like that, right? But the trick is don't go crazy. Like, that's my point. There's no perfect one, but there for sure, as Prem said, there's really bad ones. Okay? Okay, good.
All right, thanks.
Okay, thank you. Oh, there's one last one. Yeah, go ahead.
Thank you. Amazing presentation. One question. Can you go back to your previous slides? What would happen if you swap those GPT-4 or Llama model with a large reasoning model, such as O1? What do you think would happen to the performance? For example, do we still need to clarify prompt with large reasoning model? Can large reasoning model automatically reason about the imperfections in the prompt?
Yeah, that's actually a good question, because
Thank you.
The assumption of most of my work is that the LLM is still limited. It's not able to self-correct all those clear requirements. if let's say strawberry can actually clarify those things, I think we don't need it. Yeah. Cool.
Okay, thank you.
Thanks.